Hello everyone. Today we're going to be using probability and with permutations and combinations. So some probability questions will be quite rigorous, and what we'll need to do is revisit permutations and combinations, the fundamental counting principle, permutations and combinations. So permutations are when order matters, and combinations and when order is not that important. So let us define very quickly the probability of event A. Now, how we're going to take a look at this is maybe event A, we're going to define it as the number of ways A can happen divided by the total outcomes. All right. Let's go example number 1. Your bank sends you a bank card in the mail with a randomly generated 4-digit passcode. What is the probability that the 4-digit passcode will be 4 different even numbers? Well, I'm just going to write probability of 4 different even numbers. So I have to try to maybe interpret what that means. So the even numbers that I know are 0, 2, 4, 6, and 8. So the probability of 4 different even numbers, I recognize that there are 5 even numbers, or even digits. So I'm going to use how many different ways can I make up 4 different even digit passcode. Well, really, I have to select, there's 4 choices. I have to make 4 choices in the numerator. How many different possibilities are there for the first digit? Well, there's 5. And then for the second digit, since they have to be different, I'm going to take 1 out, right? And then there's going to be 4. Okay, sure. And then I have 3 left. And after I choose the third, there's only going to be 2 left. So in the denominator, the total number of outcomes. Now, how many different passwords can I, or passcodes can I make out of 4 digits? Well, there's 4 digits, 1, 2, 3, 4. So there's going to be 4 different decisions I have to make. Now, the total number of 4-digit passwords are, well, I guess I can choose, the digits are from 0 to 9, right? So there's 10 different choices. 10 times 10 times 10 times 10. I don't have to remove any of them. So if I take out my calculator, this is going to be 120 possible different ways I can make a passcode of 4 even digits that are different over 10 by 10 times 10 times 10 is going to be 10,000. So that's the probability. And the bottom should be fairly intuitive, right? You can start at having all zeros and ending at all nines and all the digits in between there, and there's going to be 10,000 different combinations of them. All right, let's move on. Example 2. A student council consists of 9 girls and 4 boys. A subcommittee will be formed to help out an upcoming dance. Determine the probability that there will be 3 girls and 2 boys on the subcommittee. So we could make subcommittees of 5 people for sure. So I need to figure out the probability of 3 girls and 2 boys. So I need to figure out how many different ways can I create a subcommittee of 3 girls and 2 boys, right? And that is going to be, well, I'm going to choose 3 girls. So I need to choose 3 girls out of 9 to go on my subcommittee. And let's move on to the boys. So the boys, I have 5 to choose from, and I need to choose 2 boys out of 5. So now, how many different, in the bottom, how many different ways can I make a subcommittee of 5 students? Well, if I take a look, there is 16 people. So how many different ways can I choose 5 people from 16? Well, that's 16, choose 5. And what I get here is 164, I'm going to use my calculator for this, obviously, divided by 4,368. So let's move on to the next question. Example 3. The YIP club has 13 members. The club needs to send 3 members to a conference. What is the probability that they'll all be boys? So the probability of all boys is in the numerator. I need to count up the number of ways that I can send all boys. So, in other words, we're sending 3 members, but there's a total of 5 boys. I can ask myself, how many different ways are there to choose 3 boys from a group of 5? So this, the numerator, is the number of ways I can choose 3 boys out of a group of 5. So that's the number of ways. Now, here, the probability is what's in the bottom. Well, the bottom really is, well, we have 13 members, and we're sending 3 away. So the total number of combinations that we could make, we could choose 3 members out of a total of 13, regardless of boy or girl, is going to be 13 choose 3. And when I take out my calculator here, in the top, I get 10 over 286. Now, naturally, I could reduce that, but I don't need to.